So now we're going to start section 6.1 by discussing angle measurement. So we're kind of moving away from the unit circle for just a minute and just talking about strictly the geometry of angles. And so an angle has two different things, we'll give them names. One is the terminal side, and then the other side called the initial side. We start from the initial side and rotate around with the terminal side. And so the convention here is if we're going in a counterclockwise rotation, then that would be a positive angle value. However, if we were to take and rotate in a clockwise direction instead, we measure the angle, but the value of the measure of the angle would be a negative number instead. So kind of the same idea from the unit circle, where clockwise result in a negative and counterclockwise result in a positive number, just as a convention to help us differentiate between the two different directions of rotation. Now we oftentimes measure angles in degrees, like 60 degrees or 50 degrees or 360 degrees completely around one rotation. But there's an alternative means of measuring angles called radian measurement. In radian measurement, our angle is located here on a circle. And so we're going to give a symbol to stand for how big this angle is. We're going to give the symbol theta. And so how big this angle is in radian measurement will be determined by the size of the arc, which is cut off by the two sides of the angle. And so how we're going to define this is radians are going to measure the length of the arc in the circle of radius 1. So we do specify that we're dealing with the unit circle here, just like we were doing before. And so that also corresponds to the values of t that we were using that measured how far we traveled along the unit circle. So in this case, we're going to consider it like an arc length of the arc, and we're going to call that measurement for our angles as the radian measurement. Now let's think about some of the more common angles we talk about in degrees. For instance, an angle like this. This would be 90 degrees. But what is that corresponding to in terms of radians? Well, our arc length is like a quarter rotation, and we called that pi over 2. So pi over 2 in radians is the same thing as 90 degrees. And similarly, if we had an angle that just turned into a flat line, like so, that would be 180 degrees. But that would also be considered pi in radians. So pi, and we'll abbreviate radians as RAD, is equal to 180 degrees. Now if we made another rotation around like this, down to here, that would be 270 degrees. But the length of the arc that goes all the way around to there also corresponds to 3 pi over 2 on the unit circle. So 3 pi over 2 radians is equal to 270 degrees. And then if we make a full rotation around, like so, that would be again 360 degrees in that measurement. But if we measure the arc length, the circumference from around the unit circle, that was called 2 pi. So 2 pi radians is equal to 360 degrees. Now the connection we can make between radians and degrees and the way we can convert between the two is by using this process here. So to convert from degrees into radians, we multiply by pi over 180. To convert from radians to degrees, we multiply by 180 over pi. So let's take a look at 60 degrees. I want to convert that into radians. To do that, I'll take 60 degrees and multiply that by pi over 180. That would look like 60 pi over 180, and that would be pi over 3 radians. And let's say we want to convert pi over 6 radians into degrees. We can do that by taking pi over 6 and multiplying that by 180 over pi. So that would look like 180 pi over 6 pi, but we can reduce that further into just 30 degrees. And one way I try to keep these back and forth here, keep these clear which one to use, is if I put the pi underneath 180 over pi, then that's going to get rid of the pi on top, and that's how we convert it into degrees. But if I put the pi on top, pi over 180, that's like most radians measurements have a pi over something. So 180, pi over 180 is how I convert into radians, but putting 180 over pi is how we convert into degrees. Now we're going to talk about angles in standard position and coterminal angles. So we say that an angle is in standard position if its vertex is at the origin and its initial side is on the x-axis. So in other words, we're starting our angle from the x-axis and rotating in a clockwise or counterclockwise direction. So and our vertex is here right at the origin. So if we put our angle like this, it's called standard position. And we can talk about two angles being coterminal if they're in standard position and if their sides coincide with each other. So two coterminal angles would be something like if I was to rotate, like say 40 degrees, and then another angle could be made by rotating all the way back around and stopping in the same place. And that would be called a coterminal angle to the 40 degrees. So the question is, how do we figure out coterminal angles? Here's what we do. To get a coterminal angle with degrees, we add or subtract 360 degrees. So in this case, if I was to take 40 degrees and add 360 degrees, I'd come out with 400 degrees. So 400 degrees and 40 degrees fall in the same location as coterminal angles. So let's look at 60 degrees. What I'd like to do are find some angles which is coterminal. So what I'll do is start off, I'll add 360 degrees. So if we get 60 degrees plus 360 degrees, we come out with 420 degrees. That would be coterminal to 60 degrees. Since it's just made up of one 360 degree rotation back around to the same place. Alternatively, we could do the same kind of thing by subtract the 360 degrees instead. So that would look like 60 minus 360, which would turn out to be negative 300 degrees. That is also coterminal to 60 degrees. Now, if we look at radians instead of degrees, say pi over 3 radians, we can still do the coterminal situation here, but dealing with radians, what we'll do is we'll add or subtract the same thing as 360, but in radians, which would be 2 pi. So if I go over here and I add 2 pi, it would look like pi over 3 plus 2 pi. I would calculate that by doing 2 pi as 6 pi over 3. That way I can add them together and get 7 pi over 3 in radians. That would be coterminal to pi over 3. Now if I subtract 2 pi, pi over 3 minus 2 pi would be pi over 3 minus 6 pi over 3, which would be negative 5 pi over 3 in radians. And so we can do this as many times as we want, either add or subtract 2 pi for radians or 360 degrees for degrees to get coterminal angles from any starting angle value. Now we can use some of these similar ideas here just to figure out if two angles are actually coterminal to each other. So for instance, is 155 degrees coterminal to 875 degrees? Here's what I'm going to do in order to figure this out. I'm going to add 360 degrees to 155 degrees to check whether or not we can actually add up to 100 or 875. And if that happens, it is coterminal. So let's start off here. We'd have 155 degrees plus 360 degrees. That comes out to be 515 degrees. Okay, we're not to 875, so let's try it again. Let's add another 360. And if we do that, that does add up to be 875 degrees. So as a result, we can say that indeed 155 is coterminal to 875 degrees. As long as we can add enough 360s to get there, that is enough to show that it's coterminal. Now, for example 4, what we're going to do is find an angle between 0 and 360, coterminal to 1290, or another angle between 0 and 2 pi, coterminal to 55 pi over 4. All right, so how are we going to take 1290 and try to break it down to something that's just between 0 and 360? Well, in this case, what I'm going to do is I'm going to subtract 360 until it's an angle between 0 degrees and 360 degrees. So for 1290, let's see how that goes. If I subtract 360 degrees from that, I'd be left with 930 degrees. If I subtract it again, I'll come out with 570 degrees. And if I subtract it another time, I finally get down to something small enough at 210 degrees. So now I've broke it down small enough that it's now between 0 degrees and 360 degrees, which means it's within one rotation around the circle. And so that would also be coterminal to 1290 degrees. Okay, and now for the 55 pi over 4, what I'm going to do is, since this is radians, I'm going to subtract 2 pi until we finally get down to an angle between 0 and 2 pi. So how that's going to go is we start with 55 pi over 4 minus 2 pi. I'll consider the 2 pi here as 8 pi over 4. And if I do the subtraction, I'd be left with 47 pi over 4. Still not small enough, so we're going to keep subtracting 8 pi over 4 here. If I subtract it again, I'll come out with 39 pi over 4. Still a little bit too big, so I'll subtract it again. And so that'll come out to be equal to 31 pi over 4, which is still too large, so I'll subtract 8 pi over 4 again. That brings it down to 23 pi over 4, which is still too big, so I'll subtract it again and get down to 15 pi over 4, which is still not small enough, so we'll subtract again another 8 pi over 4, and what we'll be left with is 7 pi over 4. Now I finally got down to a number small enough. If I try to subtract 8 again, I'm going into negative numbers. So I don't need to subtract 8 pi over 4 another time. This is now going to be between 0 and 2 pi. And that's good enough to show that this would be coterminal to the original starting angle.